Pressure vessel inspection practice according to API recommended practice 572. In this module, you shall learn about introduce to pressure vessel, understand the reason for inspection, learn about the inspection plan, frequency, extent of inspection, safety precautions, inspection methods and limitations, condition assessment and repair, inspection records and reports. Introduction. API 572 intends to provide pressure vessel inspectors with information that can improve skills and increase basic knowledge of inspection practices. We recommend studying API 572 first before looking at the API 510 inspection code, as it gives you an overall view of what the pressure vessel is about. It has many pictures that help you familiarize with various vessels and parts. In chapter 3, it explains terms and definition, which is more or less the same as chapter 3 of API 510 on definitions. So we brought it on the API 510 section. We haven't repeated here. Peruse through this section, but use API 510 section 3 for terms and definition for exam question in our module 9. Chapter 4, Introduction to Pressure Vessel. It is a container to withstand external or internal pressure constructed according to a known construction code such as ASME section 8. To qualify as a pressure vessel, the minimum pressure shall be 15 pounds per inch square or 15 psi. Pressure vessels can have many different forms. They may be spheres, balls, cylinders with various heads attached, such as spherical or ellipsoidal, and may consist outer shells, jacketed for vertical vessel, and saddles for horizontal vessel. Many methods of construction are used. The most common is a cylindrical shell made of rolled plates and welded with heads that are attached by welding. So as you can see, the head here is being formed, and then it is welded to the shell here. There might be several shell courses, and this shell is done by rolling the plates and then welding it, a longitudinal belt, butt weld. 4.2 talks about various construction methods. Read it for information only. 4.3, material of construction. Carbon steel is the most common material, maybe a potential exam question. Internals, not part of the pressure containing parts. Use of pressure vessel. There can be heat exchanger, fractionator, separator, chemical treating units. Design and construction standards. Two main pressure vessel construction code normally in the board. The American ASME Section 8 code and the British PED or Pressure Equipment Directive 5500. Both codes are more or less the same, except some parameter difference in building qualification. Since API is an American entity, ASME section codes are prevalent. ASME Section 8 has 3 divisions, 1, 2, 3. Division 1 is the most popular and also used in API exam. Any vessel above 15 psi up to 3000 psi is included in Division 1. Division 2 is for high pressure vessels, normally in the range of 3,000 to 10,000, and is more stringent. Used normally for human occupancy, divers, for example, when they come out from under the sea, so they need to go into a pressure vessel and stay there for a few hours, so their nitrogen is dissipated from their blood before coming to the ambient atmosphere. Now, Division 2, normally we say 3,000 to 10,000. It's actually more stringent than Division 1, because this is up to 10,000, but the actual Division 2 says up to 10,000. So that means you can use, depending on the purchaser's preference, they can use ASME Section 2 for less than 3,000 also. But this is normally 3,000 to 10,000. Division 3 is for pressure vessel above 10,000 psi, normally used in nuclear industries. The pressure vessel manufacturer need to have a quality manual, a quality control system in order to obtain an ASME US stamp certification from ASME, American Society of Mechanical Engineers. An ASME inspector also need to certify the vessel before the manufacturer is able to US stamp it. So there are two requirements here. One is that the manufacturer should be an ASME US stamp holder, and for that to happen, they need to have a quality manual and quality control system and should be audited and awarded the ASME US stamp certification. The second one is ASME inspector, who is from a third-party agency, an authorized inspector. When we say here, it is an ASME authorized inspector, not an API authorized inspector. Need to certify the vessel before the manufacturing, and also witness the pressure test and look at the documents to see that it's from safety points of view, and also look at the NDT records. And then sign off the documents. At that point, the nameplate can be affixed by the manufacturer, the US stamp. Under normal condition, at least one thickness reading per shell ring is required, because that may be representative of the corrosion rate. But then it is at the discretion of the inspector how many thickness measurement that he wants to be done. Protective coating and insulation should be inspected for their condition. There can be rust spot or blistering. There are common problems with paints, which are easily found by visual inspection. Scraping away a loose coating film will often reveal corrosion pits. These pits should be measured for depth and appropriate action taken. Insulation can usually be effectively inspected. If an area of insulation is suspected, samples may be cut out and examined for its condition. Insulation supporting clips, angles, bands, and wires should be examined because that's very prone to corrosion. Use eddy current for measuring metal thickness under insulation. Poor heat treatment, carburization, and other problems that can result change in hardness can be detected by a portable hardness tester such as Brinell. There might be a question coming, what is the most popular hardness tester? And that's Brinell. Positive material identification will reveal the type of metal and therefore would determine if the wrong metal has been installed, possibly during a previous repair. Magnetic tests are used to determine if materials such as austenitic stainless steel, normally non-magnetic, have been carburized, which will allow the austenitic stainless steel to become attracted to magnet. So they will become magnetized and ferromagnetic if they are carburized stainless steel. A simple magnetic check can reveal that. Chapter 5, reasons for inspection. Inspector to identify the type of damage mechanism in collaboration with corrosion specialists, determine the corrosion rate and document the overall state of the vessel. The inspection report would be the basis for future inspection and any necessary repair. Inspection is aimed at avoiding any unplanned failure such as leakage. So that is the reason for inspection, to determine the damage mechanism, to avoid any unplanned failure such as leakage, and be used for any repair. NDE techniques, fitness for service 579, risk-based inspection 580 are the complementing inspection tool. There might be a question that what is the recommended practice for FFS, fitness for service, or for risk-based inspection? And the answer is 579 or 580. It is required by state or legal regulation to perform inspection as per 510 inspection code. Inspection plan. In order to assess vessel condition in an organized manner, we need a plan. The inspection plan should take into account the damage mechanism. So you can find the appropriate NDE technique to capture it. Where to look for damages, the inspection location, be able to determine the remaining life and hence the corrosion rate, as well as the inspection interval. Determine type of inspection, whether external from outside on a stream during operation or internal from inside. And finally, take into account the preparatory work to carry the inspection in a safe manner, in the sense that you need to isolate the vessel by blinding or closing the inlets and outlets, gas test prior to vessel entry to ensure that no toxic fumes exist, provisions such as ladder or scaffolding to access the vessel, cordoning off the vessel from non-relevant personnel, having somebody on the watch at the vessel manhole to also warn other people around the vessel, as well as observe the surrounding, as well as checking on the inspector while he's doing so that to see that he's safe, and evaluate risk and either eliminate or mitigate them. Inspection plan shall be reviewed whenever there is a process change, vessel operating outside its integrity operating window, IOW, or in case of any major repair or alteration to see whether such changes affect the damage mechanism, the corrosion rate, and the remaining life. RBI considers the probability of a possible failure and its consequence. This would help to direct inspection activities to more critical areas and possibly reduce inspection interval of less critical areas. RBI together with FFS also helps determine the inspection interval. Chapter 7, frequency and extent of inspection. Frequency of inspection mainly depends on the vessel remaining life, corrosion rate, and risk of failure and its consequence. Inspection should also comply with API 510 inspection code regarding maximum inspection interval requirements. For example, 5 years maximum for external inspection and 10 years maximum for internal inspection. Safety precautions and preparatory work. Before inspection, many safety measures need to be taken into account: isolating, cleaning, and purging the vessel, gas test to ensure no toxic fume exists, else using breathing apparatus, lighting and scaffolding that may be needed, check if inspection tools are available, and there is a list at section 8.2 for that. For safety measures, you should always consult with API publication 2217, which is a guideline for work in inert confined spaces in petroleum industry. So if they say what is the guideline for inert confined space, is API 22.7. All 2000 series of API, they are safety. Just remember this, please. Chapter 9, inspection methods and limitations. There are lots of useful information with plenty of pictures brought in this chapter of API 572 highlight, and potential questions are also brought here. Check vessel construction detail, material of construction, design code through manufacturer's data book. Check previous inspection reports, carry external, on-stream, or internal inspection as per plan. Supervise NDT examinations such as thickness measurement at the conditioning monitoring locations. The CML or conditioning monitoring locations are locations that are expected to have the maximum corrosion or damage. And normally API says that should be representative of the corrosion behavior that was when selecting the CML. Determine corrosion rate, comparing current thickness with previous measurement. Determine remaining life by deducting current thickness from retiring thickness divided by average annual corrosion rate. Nozzle reinforcement cannot be used for corrosion allowance because they are reserved for reinforcement, obviously. External inspection. First, start with the ladder, staircase, walkway, guardrail, flooring, platform, and foundation. These also to ensure that it's safe to continue the external inspection. Look for loose nuts, broken parts, and corroded material. Visually inspect them and maybe hammer tested for tightness. We have a different sound when there is a crack in it, when you hammer test it. Anchor bolts can be examined by scraping away and looking for corrosion. The soundness can be determined again with a blow of a hammer to the side of the bolt or it's not. It's got a different sound. Since corrosion is most likely to occur where water can collect, these areas should be inspected carefully using a pick or similar object like a saddle. Look around nozzles, belts, and metals that are in contact with concrete for any corrosion. Check for any vessel settlement with a plumb line to ensure it's even. So it's practically a string with a weight at the end of it, and the other end is from, you start from the point you want to measure the settlement. And the distance, if the distance changes between the string and the vessel, that shows that it's actually is not straight away, it's not vertical, for example, and that shows the settlement. Diameter measurements is taken each 60 degree, 6 reading for 360 degree, and guide wire clips shall be on the live or long end, while U-bolt shall be on the dead or short end. So this can be potential exam question. Guide wire always on live or long end, and U-bolt on the dead end or short end. Beep holes on nozzle reinforcing plate shall remain open in order to detect any leaking. Grounding resistance, preferably 5 ohms, but under no circumstances more than 25 ohms. The earthing. Under normal condition, at least 1 thickness reading per shell ring. Protective coating and insulation should be inspected for their condition. Again, rust spot or blistering are common problems. Scraping away a loose coating film will often reveal corrosion pits, and they should be measured with the pit depth measurement instruments. Installation can be effectively visually inspected. If an area of insulation is suspected, cut the samples, examine for the condition, and also look for supporting clips, angles, bands, and wires where they might be susceptible to corrosion. Again, UT pulsed ET for measuring metal thickness under insulation. So if they ask you what is the NDE technique for measuring corrosion under insulation, it's ET, eddy current test. Portable hardness tester, Brinell, detect pour treatment, carburization. Positive material identification, reveal type of metal to determine if the wrong metal was used, say previously, say during the previous repair. And if you do a simple magnetic test, use a magnet. And if the austenitic stainless steel attracts a magnet, that means it's carburized. It's a very simple technique. Internal inspection, on a stream inspection can substitute internal inspection for certain requirements. These are the corrosion rate is not more than 0.005 inch, and the next inspection interval calculation shows that it's more than 10 years. So then you can do on a stream inspection. A preliminary inspection before cleaning the internals may be useful to look at the deposits and the sludge if possible. So before you clean it, you want to see the evidence, for sludge or deposits. Detailed internal inspections should start at one end of the vessel, progress to the other end. Systematic approach, such as an item checklist, will help prevent overlooking hidden but important areas. Look at the bottom and head, also liquid level line around the trays. And if you suspect any damage or corrosion under the trays, then remove the tray to look under it. Look at the impingement place for excessive erosion between dissimilar metals for corrosion, high stress areas such as sharp edges or for any crack, downstream of injection points for corrosion. Bulges and buckling usually indicate cracking and should be inspected more thoroughly. Any severely corroded internals may be replaced. Any loose internals may be repaired. Carry a thorough thickness measuring. Look for thinning and pitting. Carry PT or MT examination of selected areas for crack, check for lamination using a UT compression 0-degree probe. So if they ask you what is the lamination check, you say it's a UT compression 0-degree or normal probe. Blistering can be detected by running a flash light parallel to the surface. So if you hold the torch parallel to the surface and look from behind the torch, if there is a blister, you can see it clearly. Perform out of roundness check for deformation using a plumb line or straight edge. Light tapping by hammer would reveal soundness of metal. However, please remember that vessel under pressure is not recommended to be hammer tested. Because already under pressure, it might break. So this can be a potential exam question. Can you hammer test while the vessel is under pressure? And the answer is no. Look for disbonded or crack lining. A very useful method of tracking the corrosion rate of lining is by welding of small tabs at the right angles to the lining when the lining is first installed. This is called protrusion leg. These tabs are made of same material and thickness as the lining, can be easily measured at the time of installation and the next inspection to determine the rate of corrosion taking place. Remember that because it's corroded from both ends, so whatever you get as a corrosion loss, it should be divided by 2. Non-metallic lining can be inspected visually by a spark tester or a Halliday tester. So the practically Halliday tester is creating a circuit between the base metal and the Halliday tester's tip. So if there is a hole in the coating, it will pass through and you see a spark. So that's why they call it a spark tester or Halliday tester. Actually, Halliday here means hole. Right voltage need to be selected appropriate to non-metallic lining thickness, else electricity might pass through the lining and damage it. So you have to make sure that the voltage is appropriate because coating is actually an insulation, electrical insulation as well. But then if the voltage is too much, it passes through the insulation and actually makes a hole in it. So, and it's always done once only. You can't repeat this Halliday testing again and again because you might damage the coating. Thickness measurement techniques such as ultrasonic profile radiography, corrosion buttons, and drilling of test holes are used to determine if any wall loss has occurred. The acid etching allows fine crust to stand out in contrast to the base metal. Testing. Any major work, repair work or alteration, then a pressure test is normally required. If the vessel's support cannot hold the weight of the fluid during hydro test or the vessel cannot tolerate contamination by the testing fluid, a gas test may be used. Pneumatic testing by its nature can be more dangerous than hydrostatic testing. Extreme caution is always advisable during the pneumatic test. The reason is that gas, when compressed, has a great deal of stored energy, and if failure occurs, it may result in explosion, losing property and even human lives. Have you ever blown out a car tire? During a pneumatic test, the soap solution is often applied to weld seams and fittings, looking for bubbles as an indication of leak. Sometimes a squeeze test, 50% gas, 50% fluid test is used for pressure test. Testing temperature can be very important with some pressure vessel materials such as carbon steel due to brittle characteristics of these metals at low temperatures. The ASME code recommends that the test temperatures be at least 30 degrees above the minimum design metal temperature to prevent the risk of brittle fracture. However, API 510 inspection code 30 degrees Fahrenheit above the minimum design metal temperature for vessel wall thickness over 2 inch and 10 degrees above the minimum design metal temperature for vessel wall thickness 2 inch and less. So this would prevail during the exam, unless they specifically ask for ASME section 8. Maximum temperature should not be more than 120 degrees unless otherwise specifically required. Section 10 is about condition assessment and repair, determining remaining life, joint efficiency, repair and alteration, and repair, And section 10 is about the records, and that's easy for you to look at it. There are 3 types: original construction records, manufacturer record book, field notes, data gathered progressively. Reports also include all the measurement, repair, and recommendation, including type, location, reason, and target completion date. Remember, there should be a target completion date on any plan and repair. Appendix A talks about exchanger. Appendix B, towers. They are excellent source of information. Heat exchanger are used to transfer heat from one gas or liquid to another gas or liquid without the two fluids mixing. Heat exchangers fall into classes condensers and coolers. A condenser has the effect of changing gas fluid to a liquid or partial liquid fluid, and ordinarily use water as a coolant. Coolant lowers the temperature of a fluid and may use water or another processed fluid of a lower temperature as the coolant. Sometimes air is used to lower the temperature of fluid. This equipment is then referred to as air cooler. Appendix C includes sample records, inspection records forms that are helpful to understand how inspection reports are prepared. We recommend that you go through them to get the idea. Thank you.